So now that I showed you how to prove that two matrices are inverses, the question is, how do you find that inverse to begin with? Because later on, I'm going to show you that an inverse matrix, there's a couple different uses for it. Today, I'm going to show you how you could use it to solve a system of equations. Later on in this chapter, there is a method where you can create coded messages using matrices, and the way to decode them is to use the inverse matrix. So they have multiple purposes, different things you can use them for. So how do you find an inverse matrix? So this may look confusing in what I'm saying here, but first you're going to have your matrix you have to begin with. That is A. Okay, so A, you're going to write like this A. If I was doing this for this process, this is what I would start with. It says, given the matrix A, join A and its identity matrix. So if I didn't know matrix B here, and I was trying to find that inverse matrix, I'd be starting off with A here. So this step would look like this. I'd have 1, -1, -1, 2. But it says, and the identity matrix that goes with it. That's a 2 by 2. So the identity matrix that goes with it would be a 1, 0, 0, 1. So you're putting two matrices together. You're taking your original matrix and you're taking the identity matrix and you're turning it into one big matrix. Okay? You with me so far? Hopefully. The second step is then to row reduce A, so the left side, the stuff that I have in purple, we're going to row reduce A and turn it into the identity matrix. So what you do is you use the skills we've been doing here recently to do reduced row echelon form, and you take this and you turn it into 1, 0, 0, 1. So you take the 1 and you multiply it by 1 and add it to this -1 to make that a 0. And then once that happens, you're going to do whatever you need to do to make that a 1, and then do whatever you need to do to make that a 0. So we've done that recently with reduced row echelon form. What happens is these numbers over here will then change at the same time. While you're transforming these things in purple to 1s and 0s, these numbers that are in green are going to change, and they're going to become 2, 1, 1, 1 in this case, which is the inverse matrix that we found before. So that's what ends up happening, is that by switching the left side into the identity matrix, the right side becomes the inverse of the original matrix. And then if you want to verify that it actually works, you would then check by multiplying the two matrices together like we did in this example number 1 to prove that they are actually inverses. So I'm going to demonstrate that for you. Let's do that. So I'm just going to pull up a blank page. We're going to start off with A here. So my original matrix A. So this left side is going to be matrix A, and that was -1, 1, -2, 1. On the right side, I'm going to put the identity matrix, so I'm going to put 1, 0, 0, 1 to create this matrix. So what I'm going to do, did I copy something down wrong? I don't think I did. Okay. I feel like I did in the previous thing, but whatever. All right, so no, this is a different problem. So this was 1, let me back up a second. The one I gave you before was 1, -1, so I'm looking at the wrong one. 1, -1, and it was -1, 2. Okay, so I'm doing the same, this is the matrix A from example 1. And I'm going to show you how we could find that matrix. So I would take this entire row, row 1, and I'm going to add it to row 2 and replace it. So first row, 1, -1, 1, 0, doesn't change. This row, 1 plus -1 would be 0. -1 plus 2 would be a 1. That made that pretty easy. 1 plus 0 is 1, and 0 plus 1 is 1. So by doing that, that's the first thing that happens. So not only did it get a 0 in this spot, it got me a 1 in this spot as well. So the only thing I have left that I need to do in this case is I need to get rid of this. So I'm going to take row 2 and add it to row 1. So the bottom row, 0, 1, 1, 1, doesn't change. If I take this row and add it to that one, 0 plus 1 is still a 1. 1 plus negative 1 is a 0. 1 plus 1 is 2. And 1 plus 0 is 1. What I end up with in this case, this side right here, if this in blue was A, that right there is now the inverse of A, which I called matrix B in example number 1. So, what I want you to do, so pause this video. Actually, I'll just end this video, but before you go on to the next video, I want you to go through and try to find the inverse of matrix A and matrix B. And notice it says, if it exists. So if you cannot get it to the 1s and 0s on the left side, then that means that it doesn't exist. Not every matrix has an inverse. So I'm going to give you guys a minute to do that. For those of you watching videos, you just have to go on to the next video after you've tried these.